Hello, welcome to the Grademetrix Excavator Solutions webinar. We here at Hemisphere would like to welcome you to our solutions on the excavator that we have made for our customers. We appreciate you taking the time to join us today. We have several different systems that we'll go through. On the right-hand side of the screen, you will see a chat box that will provide you some interaction if you have a question that you would like to ask someone from our team. We'll also have some follow-up one-on-one discussions that can be scheduled if you would like a deeper presentation of these systems. At the top of the chat box, you will see a call out for handouts where you will be able to download our brochures for each one of our systems. We really appreciate you taking the time today to go through our webinar on the excavators. Our agenda will be we'll go through the introduction of our team for the Americas, the key features overall of our excavator systems, the key benefits, the technology behind the systems, the actual solutions themselves. My partner, Todd, has prepared a simulation for you from the operator seat. We'll show you how our software interfaces with you while you're using it. We'll talk about our promotion for the United States, and then we'll wrap up with some additional questions if we have time. We anticipate that this webinar will go between 35 and 40 minutes today. We've been running these webinars for the last several weeks. If you have attended one of our other webinars, either for the dozer or for site metrics, some of the slides and material may look the same. There is unique material here specific to excavators, and we are really happy to be able to present it to you today. My name is Jason Kilpack. I'm the Director of Business Development for Machine Control for Hemisphere for the Americas. My partner is Todd Medine. He's our Field Applications Engineer for Machine Control for the Americas. I have 25 plus years experience working for several manufacturers in this industry, and I'm very proud to be a part of this initiative we have here at Hemisphere. Todd has several decades of experience working with several manufacturers in the positioning side of the business as well. He does have a small leg up on me because he started in this business as a qualified operator. He's qualified to operate motor graders, dozers, excavators, and several other excavation machines, and has a great perspective on how this technology can help you in the field today. We would like to be considered as a reference or as a resource for you moving forward. We both have quite a bit of experience in this field and with this technology, and we are very excited to bring this here to you today. So what are the key features of our excavator systems? Well, there are very simple systems to install and to operate. They offer you two-dimensional, or what we would call 2.5D solutions, as well as 3D solutions. In the upper right-hand corner of your screen, you'll see the ruggedized case that's an option for you. Inside the case is the receiver, the two antennas, and the display, along with the sensors that attach to your machine. These are rugged solid-state sensors. This is the only excavator system of its type at this price range that offers a 3-year warranty out of the box. It's very easy and quick to install with an install and calibration time of less than 8 hours. We have solutions that will fit any size excavator, for a mini, a compact, or a standard size excavator. What we're really excited about for you, our customers, is the simplified user interface. We have tried to reduce the number of buttons and options for your user to interface with the system to be productive. Our system provides a dynamic cut and fill to an engineered surface or to a surface that you yourself can create in the field without any plans at all. More importantly, our system provides industry standard file support. We manage to get through life without having proprietary file structures that need to have proprietary software to talk to our machines. That means that somebody that's creating blueprints for you today on your designs can simply export a DXF, DWG, land XML file, and it will go directly into our Iron One running our grademetrix software. Also, this means that any qualified model builder that's in the industry today can also export or translate a file for you very simply and easily. The other thing that we offer with this system is our in-field design support. This allows you, without any design at all, with just a fixed position with your machine, to build flat pads, single, dual, multiple slope pads, simplified roads, ditches, any kind of a surface feature that you would need to do without having to have a design file at all. This system will cut to a design, whether it is an industry standard engineered design that you've received from an engineer or a general, or something that you've created in your display by yourself. It will create the design, and you can cut or fill to that design. Also, it will allow you to take topo points and label those points for later use. The example would be if you're having to move some material around and you've got an asset in the ground that you're going to end up covering for a period of time. You can put the bucket teeth over that manhole, over that invert, whatever it is, create a topo point, label it, store it, and move on with your day. Whenever you need to go back and uncover that asset, you can stake out to that position and know exactly how far away the bucket teeth are from that covered item or interest point. So what are the benefits? Most of us that have been in this business for quite some time are familiar with multiple different studies that show that grade control technology improves efficiency and reduces overhead. Some of those are wide-ranging claims that go anywhere from 30 to 35, 40% in reduction or profitability increase. Overall, if you're sitting through these webinars, you are considering how you can get some technology to help reduce your labor, help reduce your fuel cost, and help reduce your overall overhead of your efforts. And this system will do that. It'll provide a simplified interface for you to learn, for your other operators to learn. And moreover, this technology improves all operator skills. If an operator, whatever their experience level is, knows where they need to excavate to or to fill to in their cab in real time, they can do it faster and more accurately. The other benefit is this is a non-proprietary file standard format. That means that we don't sell you extra software or make it difficult for you to bring in industry standard files. There's no translation needed out of most of the standard file structures, which Todd will cover a little bit further in his presentation later to come. Anytime your vehicle touches material on your job site, it costs money. It costs money to transport that vehicle to the job site. It costs money for maintenance on the vehicle, fuel for the vehicle, a person to operate the vehicle. As you're moving material, if you are more accurate in your measurement of the thickness of that material, you can save money on the material. If you're saving the time to move the material, you're saving your overhead. We will make a claim that you can get 20% improvement just in your efficiency on your job site by adding our system onto your machine. This will allow you to be faster to completion and without the holdups. We've all had the opportunity to be on a job site where a control point or a grade stake has been knocked over that's a key for us to finish, and we've had to call someone and wait for them to come and reestablish that measurement for us. This allows you to have the measurements in the cab of your machine while you're working. You can operate completely stakeless if you want to, but the most important thing is it allows you to have complete control over your job site. So what's in the technology inside of this machine? Well, all of these systems that are available today utilize global navigation satellite signals. Those signals are produced by several different constellations from several different countries. The primary ones that have always been used are the GPS system from the United States and the GLONASS system from the Russian Federation. More recently, the Galileo system from the European Union was introduced and was operational, as well as the Baidu system from China, which is now operational. Previously, most systems that operated in this space utilized GLONASS and GPS only. That would be represented in the sky plot on the lower right-hand side of your screen. That would be tracking and utilizing approximately 22 satellites that might be in view. Although this was an improvement on GPS alone for machine control because you have more satellites, it still offers some weakness because there are still times when local conditions will prevent a machine from operating as expected because of the lack of satellite signal. On the upper right-hand side of your screen, you see the grademetrix sky plot. This is in the same location, tracking all 4 of the major global constellations. So we're tracking 24 more satellites, using 24 more satellites in our solution. So you're going from 22 satellites to 46 satellites. What does that mean for you? If you're working on an open job site where there are no other blockages of signal, there's no problems, the sky plot on the lower side of the screen will work just fine for you. However, if you are starting to work in an area where you've got a high side cut, you've got foliage from trees, you've got an urban canyon where you're working, where there's multi-story buildings around you in an urban environment, the more satellites that you are tracking and utilizing in your solution on your excavator is directly related to what your performance is and how productive you are. If you are tracking all available satellites in the sky, you have the best possible ability to get your job done the fastest. All signals, all activations for Hemisphere machine control products are included in one price. You will always have the sky plot you see at the top of your screen with a Hemisphere receiver on your machine. You can, in some cases, pay extra from other manufacturers to get a similar sky plot, but know that you will have to pay extra for that. The technology inside of these receivers is the most modern than in any machine control receiver system. The receivers we'll talk about today will track over 1,100 channels. They have the ability to track every signal that's being broadcast now and any additional signal that might be introduced into the future. They run the latest RTK engine that was announced in September of last year. If you're in this business and you have seen these systems operate before, maybe worked with a different manufacturer, ask them how many channels their receiver tracks and utilizes. Ask them how old their RTK engine is. We believe this to be the most advanced positioning system in the marketplace today for machine control. So we'll go quickly through a couple of the different kits. The first one I'll talk about is our compact excavator kit. This is unique in the marketplace. The VR500 appliance is an all-in-one receiver. It has a primary and a secondary antenna built in. It has all of the hardware needed to operate built inside of it. It has a web UI, it has Bluetooth, it has Wi-Fi, it has a UHF radio that's all built in. A single cable connects it to the harness for the rest of the system. It'll fit on a roll bar of a mini excavator or on the top of the roof of a cabin of a compact excavator. The limitation for this unit is the reach of the boom and the stick on the machine. we suggest a 10-ton or less excavator that has a reach of 12 feet or 4 meters. Anything more, we need to spread the antennas out a little farther than the VR500 allows us to do. But for a compact or a mini excavator, this is an absolute home run product. Everything fits in the optional case you see up above. The display, the 4 sensors. The 4 sensors are on the body, the stick, the boom, and the dog bone. It's a massless excavator solution, very easy to install. It has the option of a laser receiver kit that will pick up a laser signal from any of the common rotating lasers that are on the market today. It also supports tilt buckets. If you have a steel wrist or a rototilt, very simple to integrate there and offer you tilt bucket function. It again has the same features of the main benefits that I talked about previously with the simplified user interface, the dynamic cut and fill to a surface, and the support of all the industry standard file formats. Use this to optimize your compact excavator in the field. Use it to build flat pads, single, dual, multiple slopes, simplified roads, anything, and use it with or without a design. On our standard excavator kit, we have our VR1000 receiver. That's the only significant change between the compact and the regular large excavator kit. That is just so that we can spread the antenna length between the primary and the secondary antenna to a wider stance to give us a better heading for a longer stick and boom reach. This will support long reach rigs for large excavators and anything pretty much 10 tons and up, this receiver will fit on. Both the VR500 and the VR1000 receivers are originally built to OEM spec for a heavy equipment manufacturer. They are designed to operate at 158 degrees Fahrenheit without any vibration mounting in any orientation, and they are impervious to water. They can be stored or operated at negative 40 degrees Fahrenheit as well if you work in a cold weather environment. They all come with a 3-year warranty on the primary parts of the kit. They all have the same functionality with the optional laser receiver kit, the optional tilt bucket kit, and support of all of the standard features that I just went over with the previous compact excavator. Now I'm going to turn it over to my partner, Todd, and Todd's going to actually give you a quick overview of what it looks like in the screen while you're sitting in the seat of the excavator. Todd?
Thank you for the introduction, Jason. As Jason mentioned, I'm the field application engineer for Hemisphere in North America. Today, I will be running you through a brief overview of grademetrix. I will start with how the machine operator would use the system to grade with an excavator. Currently, we have 3 different ways the operator can set the machine up to get cut or fill. The first would be creating a job inside of grademetrix. This option would be used if the project had been designed by an engineer and the job has a set of blueprints or plans. These plans will be based off a known horizontal and vertical grid that the machine will have to match. I have an example of a job loaded and shown here. Notice all of the grade breaks shown on the side of the road in the cross-section view. This is showing you an image of the excavator bucket as you are looking at it from the cab. The red is the surface that we are wanting to cut or fill to. If I zoom in on the plan view and start to approach the curb, you will notice that both the plan and cross-section views change to reflect the location of the machine. Along with the cross-section view, the operator can use the light bar located here on the left side of the screen to adjust the bucket to maintain grade. Watch when I go past the back of curb. The light bar will now indicate that I have a foot plus of fill. Now, when I go back into the road prism, it returns to grade. Grademetrix has additional views that will help the operator maintain grade. These can be found by using the icon in the upper right-hand corner. Some of my favorites to use are plan, section, and profile. If cutting or filling a slope, the profile image here in the lower right will show the operator where grade is. Plan and section will add a large cut fill area that is easy to see in your peripheral vision. and will also display both the current crossfall of the bucket in a percent value and also show the crossfall of the design surface directly underneath the bucket. The profile and section view is useful when we create our own designs, and you don't have to worry about any of these kind of grade breaks. For now, I'll just stay on plan, section, and profile. If the operator would want additional information like elevation or design elevation, it can be found in the information summary. Simply tap on the icon here to open. It will display a multitude of information that can be customized to show more or less data. It is important to note that the information summary is obtaining that information from a specific part of the machine, shown by this green triangle in the cross-section view. It is now set to bucket left. If we wanted to know what elevation we're at on the right side, you must have to click and hold on the bucket to change it. Now, the information summary data will be referred from the right side of the bucket. To close the summary, click on the same icon that opened it. When models are created for a job like this, it is generally built to a finished surface. That would be top of asphalt, concrete, or gravel, depending on the job and materials. The operator would have to offset the thickness of the material to get to subgrade. We can do this in a few different ways. Below the left light bar, you will see the up and down arrows. If we click on the down arrow, you will notice that the offset numbers change by 1/10 at a time. The upper number here is showing you how much cut or fill you have, and the lower is our offset. The cross-section view also has a new line going across it that represents our new grade. If we have a large offset or a number not divisible by 1/10, we manually enter the offset by clicking and holding on the light bar. You can manually type in the offset here. A negative number means that you want to go lower or cut more. Step is the amount of each vertical offset button will add or subtract when pushed. If the job has more than one vertical offset, for instance, one for subgrade and one for top or rock or finish course, you can save the current offset number by clicking and holding the preset, making it easier to change in the future. Guidance lines will provide us with station and offset from a selected line. This will work with any of the CAD lines that you bring in under the linework file. From the main screen views, click and hold on the line that you would like to get the stationing and offset from. A new menu will appear. Select the Use Guideline checkbox and select OK. We will now see stationing and offset while I navigate along this chosen line. Now that we know how to use grademetrix with a job that has already been loaded, I will show you how to create a job and describe the files needed to start. The top left icon is how we access the menu. The very first option is New Job. First, we name the job and click Next. The localization file is gathered by using a rover. The job or project will have known control points that are established by the surveyor in the early phases of the design process. Sometimes you will find the northing, easting, and elevation of the control on the plans, or you'll have to request them from the project owner or general. When you get the control information, you'll have to shoot each control point using a rover. All this does is equate a specific lat, long, and height to a known northing, easting, and elevation. Once complete, you save it to a thumb drive and bring it into grademetrix. We also have the capability to bring in a calibration file from Trimble Construction or export the point data needed from TalkOn, making it easier for customers with mixed fleets. The second file needed is line work. This is the lines you see in plan views and are obtained from the project engineer or model builder. We accept DXF or DWG. I now have the localization and line work file selected. When I select Next, it'll ask me for the third and final file, a surface file that contains the project's finished grade attributes elevated to the correct elevation to form a three-dimensional surface that grademetrix can read. These can be built using CAD data or line work file from the engineer and numerous different CAD package. Or nowadays, it is relatively inexpensive to get built by a model builder. We accept most common file types like DXF, DWG, XML, DTM, among others. Once you select the surface file, click Next and make sure the units are set correctly. Next, one more time to see the localization file in text format. If bringing in a Trimble Cal file, you will see the calibration residuals here, showing how accurate the localization will be. Once satisfied, finish the project. Again, the above process is used for projects that have been engineered and have a CAD file or set of plans. The second way to control cut or fill within grademetrix is field design. This is useful when the customer will not be on an engineered site or that the site will need a redesign done. We have included a few tools that will still allow the machine owner to use grademetrix in this case. You would not need to localize the site or have any of the files for this to work. All you need is RTK corrections from a base or VRS corrections from the internet. Setting a base on an unknown point and make it broadcast is easily done in Grademetrix. From the main screens, go to the menu and select Field Design. We have 4 different types of field designs that we can use. Notice that every type of field design can be named and is automatically saved for future use, making it easier to switch back and forth between saved field designs. Flat pad will create a pad at the same elevation on all sides of the machines forever. To use this, first drive the machine to a known grade or stake. If the stake has a cut or fill to the desired grade, we can fix that later in the vertical offset menu. Give the pad an appropriate name and select Record. And now Finish. You will see that the color of the surface has changed to green, and now you have a flat pad. We can still see the job's design surface in red, but if I drive over the portion sticking above the new pad, it will still give me the cut or fill to the pad, and not the design surface, making it easier to use when doing redesigns in the field. If the stake you bench on at the beginning had a cut or fill, you can easily add it by clicking and holding on the light bar and typing it in. The second field design is hold slope. This is used in conjunction with guidance lines to allow a particular percentage off a line based off the position of the bucket and the guidance line selected. To select the guidance line, tap on the line you would like to use and checkmark the Use Guideline box and press OK. Now, position the excavator with the desired bucket cross slope. The emulator does not allow me to angle the bucket, so I will only be able to show you using 0% crossfall. If I go back into field design and hold slope, I can press Record. And now Finish. You will see a new surface color holding that 0% crossfall at the guidance line's elevation. This would be useful for road slope redesigns, or if a contractor needed a place to get rid of extra material. The third option in field design is sloped pad. This will do anything a dual plane laser can do. Useful for parking lots and tie-ins between 2 known areas. To start, position the machine on a known grade or stake facing the direction of the proposed main fall slope and press Record. And then Next. You would now drive the excavator in the direction of the main fall heading, and you can also place the bucket down to establish the main fall percent between the 2 points, or you can type in the percent manually. I cannot move the excavator in the emulator while in this menu, so I'll just type in the bearing, distance, and slope and select Record. And Next. Now it is asking me for a desired cross slope. I'll give it a positive 5% so we can see it when it's finished. Now, when I track ahead, you can see the existing surface fade because of the increased slope while moving forward, and we have that 5% crossfall. The last field design we have is ramp. It is very similar to sloped pad, but it will give you the option for a grade break or 2 sloped pads based off the line that you record. Think of a V-ditch or a crowned road. This is useful for creating roads, trenches for underground, and tie-ins between 2 known areas. Just like slope pad, I will start with a known grade, elevation, or stake, and start with the machine facing the proposed main fall direction and press Record. And Next. You would again drive in the direction of the main fall to establish the bearing, and either use the bucket to create the main fall slope or enter in manually, and press Record. Since I cannot move the machine in this menu, I'll type in the bearing, distance, and slope and select Next. Now, it is wanting me to build a cross-section template. Side of center is used to tell you what side of the center line I want to project my new lane. I will give it a 12-foot width with a -2% fall on the left. And now I will do the same on the right. You could also add additional lanes to the template if needed, giving the operator the ability to build a complex model with ease. Once satisfied with the template created, just push Next and then Finish. You can now see the crowned road that we have created. 2D is the final way grademetrix is used to give cut or fill inside the cab. It is used if the machine does not have access to RTK corrections from a base or internet corrections from a VRS network. The operator will use the bucket of the machine to reference where grade is. For instance, if the operator knows a particular part of ground is at grade, or has a stake that has a known elevation or cut or fill, he can place the bucket down on that location and tell the system that is grade. Keep in mind, when using 2D, you will have to touch the same point with the bucket before and after you track the machine to compensate for the elevation change in the machine movement. We also offer an optional laser receiver to help maintain the machine's vertical position. When we go into the menu and grade 2D, you will see a list of icons on the right side. The very top icon will allow us to choose what type of 2D entity we would like to build. Every option will ask for a name and will also save the associated settings to that name so you can easily select them for later use. These are configured similarly to field design. For the sake of time, I will only briefly cover them. Flat pad will create a level pad at the same direction on all sides of the machines forever. Single slope pad will give you a pad with a single main fall percent rise or fall. Dual slope pad will give you a pad with a main fall percent and cross fall percent too. Trench is used to create a percent-based main fall baseline that, once established, will allow you to create node-based cross-section templates. This would be extremely useful for underground guys. Profile is similar to trench, but instead of creating templates used in cross-section, you will be creating them in the profile view. This would be useful if you were excavating a ditch with multiple grade breaks, and you had to excavate them from the side and not lengthwise. Once you've created a particular 2D entity, just press record and finish. You will now be in the main screen 2D view. I will lift the bucket up in the air so that it now shows that we have a cut. Let's just say this is where I'd want grademetrix to show me grade. To do this, I would bench or reference this new position using the second icon. All I have to do is press record and now finish. Now grademetrix is showing me the grade where my bucket tip is located. If I was benching on a stake with a cut or fill, I would just have to use the vertical offset tab to add or subtract the number. If you have finished the cut in front of you and need to track the machine back, you would first have to place the bucket down on a known area that can be referenced after you track the machine so that any elevation change created while moving will be zeroed out. First, place the bucket down on an area that you can reach again after you have tracked the machine back, and select the traverse icon. Notice that the icon has changed and the traversing text in the upper left. This is telling us that it's safe to move. We would track the machine back and replace the bucket on the same spot and select the icon again. The surface will adjust to our new elevation and the icon will go back to its initial state. If you think your customer will be using the 2D functionality of grademetrix often, then I would suggest adding our optional laser receiver. This will make it easier and quicker to rebench after moving the machine. Instead of tracking vertical machine movement using the above method, the operator would simply strike the receiver with a laser every time they move. Inside the Topo submenu, the excavator has the capability to manually record single points and also record points based off predetermined distances or time automatically. You can also save any points recorded to a certain file. For example, you could have a file for utilities, an existing topo, or manholes. You can also add a code description to the point by using our default selection or add your own. In the main view of Topo, you just have to choose to shoot a single shot for a manually recorded point, or you can start the auto topo using the established values in the setup menu. There is a second page to our menu that is used to change the radio channel or add login credentials for a VRS network. This is also where the install wizard is located. Equipment setup will guide you through the install process. First, name the machine and pick the units you are using to measure the machine. The next menu is asking for the model type of the GNSS receivers. For 10-ton and under 4-meter reach, you can use the VR500. For anything over that size, we would use the VR1000 so we get a larger baseline across the receivers. All of the location dimensions are automatically added after the 3D calibration is finished, so you do not have to measure these. The chassis is for scaling the image of the dozer in grademetrix. Slew offsets will automatically be populated after the 3D cal as well. Lengths are the first set of critical measurements needed. These should be within a few hundredths accuracy. Arctic boom is used for a second boom. Traditionally, we don't see many of these in North America. Laser tab is for measuring the placement of the optional laser receiver if used. The dog bone tab is also another set of critical measurements. Again, measure within a few hundredths. The bucket tab is used to measure any of the buckets the machine has. L3 will populate itself from the dog bone tab. The next menu is used to tell where the sensors are located and which way they're facing. On the excavator, we have a total of 4 sensors. They are located on the body, the boom, the stick, and the dog bone. If using a tilt bucket, you would add a 5th sensor. The sensors are shaped like an arrow, so it is easy to identify the facing. The writing on top of the sensor is used to tell the position. The final screen shows us the measurements we've inputted, verify that they are correct, and finish to save. The second step of the install process will be calibrating the sensors. First, park on a flat, level surface and line the machine up like showing on the image, with the tracks and machine body parallel to each other, and press calibrate. And next. Now the machine is flipped around. Use the compass arrow in the lower left corner. The point of the arrow should be in the green. I cannot move the machine in the emulator, so I'll just have to calibrate here. For the boom, we would use a string centered on both the boom and stick pins, held on using magnets, and using a string line level to get the boom pin and stick pin level with each other. Once completed, press calibrate. Notice there's a box in the lower left. You could use a laser or total station and add the height difference instead. The next sensor is the stick. Here we would drop a plumb bob down from the stick pin to the bucket pin. Once the two are centered and plumb, press calibrate. And next. For the dog bone, using a level, we get the dog bone pins level and press calibrate. And next, the bucket. We drop a plumb bob from the bucket pin and plumb it with the bucket tip and press calibrate. And finish to save. The final install process is the 3D calibration. The emulator doesn't properly allow me to show this step, so I can only describe it. The installer would align the machine in 90-degree segments, and the machine would record each position. Then, 5 points are recorded using the rover. These 5 points include secondary antenna position, center of the boom, center of the bucket, right bucket pin, and left bucket pin. These points are then brought into grademetrix, and the install process is complete. If you have any questions, please reach out to me personally, or you can ask them in the chat box now. I will now give it back to the presenters to answer any questions. Thank you.
As you guys can see from the software, we've tried to simplify the process, not only of operating the system, but also the install, the calibration. You can have a very good calibration without a total station or a laser. And you can use off-the-shelf tools and an RTK rover to get that accomplished on your job site. We are trying to drive a maximum return on investment to you, our customers, with this system. We're trying to make it as easy as possible to use. By doing that, we think you'll be the most successful. This is a system that will provide you world-class performance out of the box. There are no additional signal options to purchase or activations. Everything is included with this system. It has an incredible, attractive price point, which I'll cover in a minute. But moreover, it's going to add to your fleet faster because it'll allow you the faster installation and simplified calibration. Cost of ownership with these systems is important over time. There are no gotchas with a hemisphere system. The software and firmware updates that come incrementally in time are included with the purchase of your product. And it will have the best warranty in the industry, having 3 years out of the box at this price point for an excavator system is unprecedented. I'd like to touch on just a couple of items. Additionally, we have a current promotion for the United States. It's a 0% down, 0% interest, 90 days deferred payment for a total term of 27 months, but 24 months of actual payments for a compact excavator that's less than $1,200 per month. $1,166.50 actually. For a large 30-ton excavator using the VR1000 receiver, that cost is $1,250 per month. For you, our customer, to be able to have the opportunity to save 20% in labor and fuel and machine costs, how much would that be worth to you? Is it worth $1,200 a month? We think it is. And we're very excited to have this system available and shipping now. We had a couple of questions that came in, and I'll see if I can answer a couple of those on the mic. If you have any additional questions, concerns, or would like to engage for a deeper opportunity and a discussion, please contact me directly. My name's Jason Kilpack. My email address is listed there on the screen. We've had a phenomenal success with these online webinars over the last several weeks, and stay tuned. We will have more coming from Hemisphere in the future. A couple of the questions so far that I've got. What do I need to take off and on the machine in the night, in the morning? Well, the opportunity for that is for you, depending on the work area you're in. If you feel like you've got a locking cab, etc., the display has a simple connector that you can pull the display out of the mounting bracket from your seat position when you depart the cabin. And the receiver itself is inside the engine compartment, more than likely, or it's an VR500 on a smaller excavator. The VR500 has a quick release and a single cable. The VR1000 has two external antennas that simply disconnect from the mounting brackets on the counterweight of the machine. So you have very little to remove at night and very little to place back on in the morning. Does it have autos? This system, for both the larger machines and smaller machines, does not have automatics at this time. That's why it is priced the way that it is. That doesn't mean that development isn't underway for automatics. It just means that these product systems today do not provide automatic control over hydraulics. Can I use my current brand X or brand Y base receiver for a correction? Yes, you can. Keep in mind, the base receiver must be able to transmit on UHF frequency, and it must be able to provide that correction in RTCM 3.2 format. Most of the major manufacturers that are on the market today, that is a standard setting that they have. You just need to make sure you have a UHF radio that's on your base to do so. Phil says, okay, can I connect to a VRS network? Yes, you can. All of the displays that are sold with these systems have a SIM-enabled modem built in. You need to have a data plan for a SIM card to insert there, or you need to have a hotspot that you can Wi-Fi to your display. Once you've connected to the internet, you just need your connection credentials that are issued by the network provider, and you're off to the races. Okay, I think we're getting ready to wrap up here. We really appreciate your time today, and I would hope that if you have any questions or concerns, that you would please reach out and let us know how we can help you. Please consider us a resource for you in the future. We really thank you for your time and attendance today.